Hello again. So in our last video, we reviewed sine, cos, and tan, so SOHCAHTOA. And today we are going to look at sine law and cos law. So sine law is something that we can use whenever we have something called an angle side pair. So what that is if we have angle R over here, and we have its opposite side 15 centimeters. Well, now we can use sine law. And sine law works actually for every triangle. It doesn't have to be a right angle triangle like in the SOHCAHTOA solving of triangles, right? So I have R, and I'm looking for everything on this triangle actually. I can already find Q because, well, I have 60 degrees and 41 degrees. So if I wanted to find Q, I can already just use a little handy dandy law I know, which is that all of the angles in a triangle should add up to 180 degrees. So 180 degrees minus the other two angles, 60 degrees and 41 degrees, well, that should equal angle Q, right? So 180 degrees minus 60 degrees minus 40 degrees, well, that equals 80 degrees. Well, it equals 79 degrees. Close to 80, but not quite, right? So I already know angle Q, and I didn't even have to use any signs yet. But if I want to find side P and side little q over here, well, then I have to use something called sine law. So for sine law, there's two ways of writing it. If I'm looking for an angle, I like to write it like so, like the sine of one angle divided by its opposite side is equal to the sine of a different angle equal to its opposite side, and it can also be equal to the sine of the other angle in a triangle equal to its opposite side. But we only ever use two of these at a time. We never really write out all three. In this case, I'm looking for a side. So if I'm looking for a side, that actually means that that side divided by the sine of its opposite angle, right, is equal to this side that we know, which is R, divided by the sine of its opposite angle that we also know. So since I know the side that it has little r and big R, I can find the side P because I also know angle P. All right, so let's do this. I don't know what P is, but I know that the sine of P is the sine of 41, and I know little r is 15 centimeters, so the sine of R is 60 degrees. So if I'm solving for P, I'm just going to cross multiply up the sine 41. So P equals sine 41 times 15 divided by sine of 60. And then that's it. That's all I got to do. So I'm just going to plug this into my calculator. I get sine of 41 times 15 divided by sine of 60. And I get that P equals 11.36 centimeters. I'm actually going to write that in right on my triangle, 11.36 centimeters. Then all that's left is to find side Q. So Q divided by the sine of 79 degrees equals, I'm going to still use the one that I know. Even though I've just found P, I'm still going to use the one that's given to me, that 15 centimeters divided by sine of 60. So once again, looking for a side, I do sine of 79 times 15 divided by sine of 60. And Q, when I plug this into my calculator, well, Q equals 17.00. And I can even write that one on my triangle. And that's it. That's all I got to do for sine law. Of course, if I was looking for an angle, I would set it up this way, multiply the side over, and do inverse sine. That would be my only extra step in order to find the angle. Okay, so let's do cos law. Cos law is a little bit longer. It is written like so, that the c squared, so an opposite side, is equal to a squared plus b squared. Hey, that looks a lot like Pythagorean theorem. And then we add afterwards, or sorry, we subtract 2ab cos of angle C. So this is very similar to Pythagorean theorem, only it works for every triangle, not just right angle triangles. So let's look at this triangle, ABC triangle. I am given all of the sides, but no angles. So since I don't have an opposite angle side pair, that means I have to use cos law. So let's start plugging it in. Let's find this angle C over here. So C squared is 3.8 squared. A squared is 6.5 squared. B squared is 5.4 squared. And I'm subtracting from it 6.5 times 2 times 5.4. And all of that is going to equal the cos of C. So since I'm looking for an angle, I could actually rearrange this. I could rearrange this to have C on one side. So let's do that. So I've got 3.8 squared, which is my opposite side. I'm subtracting the two other sides, 6.5 squared, and I'm also subtracting 5.4 squared. And then I'm going to divide everything by -2 times A times B. So -2 times 6.5 times 5.4. And all of that equals cos of C. So it doesn't really matter which side I place as my A or my B. All that matters is that my opposite side of the angle I'm looking for is first. That's all that matters. That the opposite side is the one that has the switched sign. So everything is negative here except for my opposite side. That's really the one I need to focus on when I'm doing the cos law. The other two sides, we don't really need to worry too much about them as long as those are the ones we're putting here and that the opposite side only appears once and has an opposite sign as well. Okay, so if I plug this into my calculator, I have 3.8 squared minus 6.5 squared minus 5.4 squared, and I'm dividing it by... Make sure also when you're putting this into your calculator that you have proper brackets, right? So I recommend putting brackets around if you're doing all of this at once, put brackets around everything in the front and then divide it by putting brackets as well. And this is just something you can do to make sure that you're not accidentally dividing only one of these things and then subtracting it, because you will not get the same answer if you don't do that. So we're dividing it by -2 times 6.5 times 5.4, and I get an answer that looks something like 0.811538, etc., right? And that equals the cos of C. But don't forget, if we're looking for an angle, I have to do the inverse, right? So I have to do inverse cos, so second function cos, of whatever answer you get. And that's going to equal our angle C. So the inverse cos of my answer, and there's actually an answer button on a lot of calculators as well. Sometimes you can get it by doing shift and then over the equals button. But if your calculator is different, it might appear in a different spot for you. So if we do the inverse cos of this answer, we should get 35.75 degrees. And that equals our angle C of this triangle. So this triangle, if I were to round it to the nearest degree, is 36 degrees over there. Now once I find C, now I have an opposite side angle matching pair. Well, I can use sine law if I want to solve the rest of that triangle. I don't know why I keep getting thrown over here on my computer, but there. So to summarize, whenever we want to use sine law, we use sine law for triangles that aren't right angle triangles, but it does work for every triangle. And we have to make sure that we have that angle opposite side pair and at least one other angle or side in order to solve this triangle, right? If we have only sides, like this triangle, then we can do cos law to find the angles. If we have something like an angle but no opposite side to it, and yet we do have the sides that are next to it, well, this is what I like to call an angle sandwich. And I call it an angle sandwich because we have a side, and then smushed between them we have an angle, and then another side, right? So it's kind of like a sandwich. And what goes really well with an angle sandwich? Well, a side of cos law. And we can use cos law to find the opposite side. So if I'm going to set up this opposite side, well, here I have a squared, right? I start with my opposite side, and then it doesn't really matter what my other two sides are. So here I have b squared plus c squared, and I'm going to subtract 2 times bc cos of a, right? So if I set all of this up, I'm looking for a squared. I'm going to plug in 6 squared plus 8 squared minus 2 times 6 times 8 times the cos of 65. So a squared, when I plug all of this into my calculator, I get 6 squared plus 8 squared, subtract 2 times 6 times 8 cos of 65. And I get an answer of 59.4286, etc. So I'm going to just write 43. And this isn't done yet because this is finding a squared. If I want to find a, I actually have to take the square root of that. So I'm going to do the square root, taking the square root of my answer, and I get 7.7089, etc., etc. So I could even round it to 2 decimal places and get 7.71 centimeters. So the opposite side over here is 7.71 centimeters, right? Or if I'm rounding it to 1 decimal place, well, the other two are rounded to 1 decimal place, so I'll just do the same for this one. Then it is 7.7 centimeters, the opposite side. And now I have an angle opposite side. I can use sine law to find the angle B, and then I can find angle C by doing my 180 degrees, right? So let's go ahead and solve this using sine law. So I've got the sine of B divided by 8 centimeters is equal to the sine of 65 divided by 7.7 centimeters. So B over here, that's going to equal the inverse sine of 8 times sine of 65 divided by 7.7. So if I plug all of that into my calculator, I get 8 sine 65, dividing it by 7.7. And then I do the inverse sine of that answer, and I get that B is an angle of 70.325 degrees, right? So if I'm rounding it to the nearest degree, I'm just going to say B is 70 degrees. B is 70 degrees right here. And then last but not least, I need to find C. C is just going to equal 180 degrees minus 65 minus 70. So I plug this into my calculator. I have 180 minus 65 minus 70, and C equals 45 degrees. All right, and that's pretty much it. It doesn't really matter which order you do in this triangle because all of our angles are acute angles. And in grade 10, you don't really need to worry too much about the order in which you solve your triangle. But in general, I probably should have solved B last, right? Once I knew that this side was 7.7, I know that this side is 6 centimeters and this side is 8 centimeters. So sometimes something special happens with the largest angle. The largest angle is always opposite to our largest side, but we're going to talk about that more in grade 11 math.